As per the question I asked you regarding what are the elements, what are the actors, what are the components that we need, or let's say security experts need to finalize the context or the approach of OS hardening. Clearly, there are three components. There are three actors we saw through this chapter number 3. It starts with the updates, or starting with the updates. Talk about the updates themselves. We talk about the memory management, protecting against buffer overflow attacks, and a context of configuration or management of the operating system's preferences and administration configuration in this context. Simple. So the context of this hardening, there are three tasks to do, three approaches to do, three activities to do. Briefly, OS, whatever it is, whatever the OS is, since we are talking about system application, to harden the system, this system software, we need to manage the updates. So let's say talk about good configuration, good control of the updates. Good, when we say good, we have to know what and when to do an update. Then we have to be clearly controlling the content of a memory, specifically volatile memory, the live memory, and more precisely we talk about the RAM, against the excess of use, means the uncontrolled use of the memory. We have to control the use of the buffer specifically, because the non-desirable or the non-controlled use might lead to an overflow, a memory overflow, and specifically buffer overflow, not memory overflow, buffer overflow, which is a problem. So we have to control the use of the memory, the volatile memory. Then for administration tasks, we have to do good control, permittances and denials. We have to clearly clarify from the beginning who is allowed to use, what he is allowed to use, and so on. Configuration. This way, the OS will be actually hardened at a level that almost, we cannot say 100%, never to be 100%, but almost every behavior from within the operating system on top of the CPU would be controlled. And it will lead, this would lead the hardening of the operating system. What is the result? This would lead to a much more easier level of malware detection by the security appliances. 5 درجات في الفاينل. 5 درجات في الفاينل. If you repeat just the definition I given now regarding, if you exactly repeat the definition I given you now regarding the OS hardening, I repeat it for the last time. 5 marks في الفاينل. Who can do that? 5 درجات. Last call. Who can do that?
Again, Mr.
ما شرحته بخصوص ال OS hardening الجولية.
مستر يعني تبغى التعريف؟
ما شرحته أنا تو.
أيوة.
الجولية. Any trial? Any chance?
مستر الأنواع والتعريف خذينا بس.
Iman, I spoke in Arabic only to clarify my request. I said the definition I given now regarding the OS hardening I need you to repeat what I just given you now. Now, the few minutes passed. I given you a definition. I explained. What did I tell? How did I define that? How did I explain you this context of hardening of the operating system? The talk is to all of you. I'm giving you 5 marks. 5 درجات. It's up to you. I continue. يا خيبة المسعى. 5 درجات. Okay. This is not what we a simple briefing, and let's continue from where we stopped last class. So we were tackling the OS inputs, and we discussed the capability of the web browser to be a fraud versus the operating system, since it has a lot of entry points via which we can see a malware penetrating. I believe this was the last thing actually, which is the JavaScript, because we discussed the cookies completely, and this was the point where we stopped. Web browsers actually, they are carriers of web applications. They are carriers of web services to end users. Means every one of us, since we are using the web, now we are actually having an online class, and I'm presenting you an on-cloud application, which is here the PPT. It's a presentation. I'm giving it to you, and you are following me. That's good. But what's the concern here for us as a security view, for us as a security students or security, let's say, specialists, is that the input points that this presentation presents it to me or to you or to any user at the end of the day, it might be having the JavaScript as a technology, which is adding effects or adding functionalities to my interface. This is an input-output flow that this web browser is making to my operating system. It is causing an in-out flow that it is not visible to me directly, but for any user from external world, it might might gain access to my device through this technology. What did I say? What did I present now? A web browser uses the JavaScript. I'm repeating. I'm just explaining you. The JavaScript, the web browser is using all web browsers. They can use the JavaScript to deliver services to end users. That's great. What's the problem? The problem is that the JavaScript, they are adding in-out flow incorporated with the service required from within a web page. This control here, it runs mainly in background of the end user. He does not see everything clearly in his whatever. There are in-out flow from the web browser to the external world, and vice versa, from the external world to the web browser. This is a risky point. I can use this word, a risky point that might lead, if a successful penetration from an external candidate, can lead to a penetration success to my device, to my computer, to my environment, to my framework. Thus, the JavaScript has to be controlled. To avoid any unwanted access to my environment or to my framework, whatever. Architecture view, which actually, I'll come back to this slide. Because I still did not talk about the JavaScript. The architecture view, which we see JavaScript running in my device, is that a user requests service. The service will be delivered to him, but the JavaScript is included, is incorporated. So the JavaScript is included in the page. It's incorporated. So everything is one file completely. The service will be coming to my browser, to the user's browser. The fraud is available inside through this, due to this existence, the JavaScript. So we have to control the JavaScript either to come to my device or not. Is it allowed to come to my device or to access to be run on my device or not? JavaScript, it's actually a scripting language like the CSS, like the any scripting language that adds effects on a web solution mainly. Some history and some talk about the developer. Just give me a second. Sorry for the interruption. Great. So that's actually this scripted language. Actually, the JavaScript. Remember, it's not the Java. It's not the Java. We have a complete programming language called Java, like C++. The JavaScript is a scripted language. It's not the Java. It is to add effects. It is not a tool that we can use to create programs. It is not a tool that we can use to create programs. Okay. So great. So whatever the context actually that the JavaScript can cause. Remember that the JavaScript actually it is to run on a local computer, does not have any effect on a network. Means if I have an application that delivers to my device a JavaScript, I do not have to worry about the network where my device is. No, I have to worry only about my device only. I'm asking for example, to open Facebook, for example. Okay, the Facebook has sent his pages with, and every page with JavaScript, for example. Okay, I have to worry about my device if there is any threatened criteria due to the JavaScript, not about my network. Why? Because the JavaScript does not have any impact on the network level. Simple. Actually, the JavaScript has to be disabled by controlling its access to my device through the browser, over the browser setup or browser options. We can completely disable the JavaScript. We can enable some of the features, or we can enable completely the JavaScript, like we did with the cookies. So we have a controlling capability on top of this JavaScript. Okay, remember it is not to run something on a network. It is to run on a device only. Syntax to include actually JavaScript in the body. Simply, it's a tagging language, so we have a tag to indicate that we are starting a JavaScript, and a tag to close that JavaScript. In between, we have our commands. Those statements, they are in JavaScript. Simple, it's like HTML, but it has specific annotations, no more, no less. The script here indicates that we're using JavaScript. Script like this, start, and script like this, it closes the block of the JavaScript. This is to be included inside. This is to be included fully here, this one, inside an HTML block. And this block here of the JavaScript, it writes inside the page where it is included in a big size. Hello world, big size. Why? Because of this HTML h1. This is an HTML tag h1. Hello world only. Hello world. Hello world. That's great. So we continue. Another way, another syntax via which this is inside the page. Another syntax via which we see the JavaScript being included into a web page is by calling a JavaScript file. JavaScript file. How I knew? The extension JS. The extension JS. And this block here, to include the JavaScript inside an HTML file, it has to be put inside the head section in an HTML file. Inside the head section. Not inside the body mainly, but if it is there inside the body, it will not cause an error. It will not cause an error, but the place where to include it is inside the head by default. Unless we have a necessity to put it inside a body section. And this content of this file, it will be actually called and executed once the object, or let's say the page, has been called. We come to the next tool that web browsers support. Next tool that web browsers support. We saw the cookies, we saw the JavaScript, and now we are seeing the Java. Now we are seeing the Java. The Java is a complete programming language. Now we are not talking about scripting language. We are talking about programming language, and it is an object-oriented programming language. Means it just goes with objects to be defined separately, and to deal with a modular programming, blocks and functions separately. It means if there is an error in a block, the remainder will continue running, and there is a context of complete control of each function, something like that. So the object-oriented programming languages. We are not talking about scripting language. What does mean program or script? Here we can create a full program. We do not have to have a web page running to add an effect like the JavaScript. No. We can create a full program using this tool. Java is not run on web browser. Actually, it's not run on the web. Mainly, it is not to be run on the web. Means it is not being created or implemented to deliver services over the www environment. No, but we can run it over the web browsers using a technology which is the Java applet. Those applications here, those Java applets, they are classes created using the Java to be run on web browsers and to be sent by web servers. They are available in the host, which is a web server, and this web server will send it along with an HTML file once a user requests them. Java applet. They are sort of programs. They are classes created in Java, hosted within a web server along with the HTML files, and they would be actually sent along with the HTML solutions once the user is requesting that service. Java. The architecture via which the Java applet. Now, we know the Java, but the Java does not cause a problem to us, because the Java will not be delivered to us. It's not an issue that we have to harden our operating system against it, but we have to harden our operating system against the Java applets. Because the Java applets, they have an access to our environment through the web browsers. Java applets, they are created using Java. Architecture, once a user requests an HTML solution to be delivered over a web browser, if the web solution is made up of HTML components and Java applets, maybe one, maybe two, maybe many. The server, the host, will send each separately, indicating that this is the solution you need. The browser will render and concatenate them, visualize them to the end user, both together. The server will send each separately, but the web browser will concatenate and will merge them and display them concatenated in just one view. The user will not see this is applet, this is HTML, this is applet, this is HTML. No, he will not see like that actually. He will only simply see one solution, one interface with coherent content. What's the problem here? The problem that Java applets, they are causing an entry point inside the web browser. Because if those things here hold a malware, they would be executed and they would infect the computer, the environment. The problem here is not that they have a malware, but the problem is that the web server does not have a control on the content of this thing completely like he does for the HTML, because the web server controls HTML. The HTML is a web solution. Java is not a web solution. This is something, it is much more harder to control when we compare it with the HTML. The Java is not for the web. Thus, it is not easy to control it by web browsers. Sorry, web servers. Is it clear, please?
Yes, Mr. Clear.
Okay, we'll continue. We knew what is a Java, what are the issues, and how we can face this issue. Now the solution, the countermeasure against that. Actually, mainly we talk about sandboxing such inputs. The Java applets, they are input points, or they are in singular. A Java applet is it's a single input point to a web browser. So we have to sandbox the Java applet. What does it mean sandbox? Sand. Literally saying sand. Arabic. Rimal or raml. What does it mean raml? Actually, it is an area where everything will not find an easy path. Nothing. If you walk on a sand, it's much more harder when you walk on the asphalt, on the roadside. It's not the same way. On the sand, the work is very hard. So from that aspect, the sandbox will behave. The sandbox, it's a much more control, let's say, settings when we compare it with a normal environment. So there will be very hard control. You cannot pass any software. Will not pass through this sandbox. The sandbox itself is a software. The sandbox, or a list of software that would control all the software. Actually, in our case here, we talk about the Java applets. Java applet, or Java applets in plural. So in our case, we are controlling the Java applet with a lot of control. Sandboxing. There are two types of Java applets. At the end of the day, there are two types of the Java apps. Java apps is not it's not a harmful program. The Java apps, they are not a harmful program. Now we are seeing that it is dangerous. Absolutely true. But from the original state, it's not a malware. It is a technology that delivers services. It is a technology that do deliver a service or a services, group of services in plural. And this sounds off. See here, this is a login interface. It is to deliver a service over the web. And here we know that it is unsigned Java applet. Why? Because the interface here showing us a warning. Hey, this is a problem. The applet here is not signed. It's not trusted means. Unsigned Java applet. What does it mean, signed and unsigned? Those are the two types of the Java applets. Java applets which are not secured, and Java applets that they are secured. In the sense of here, the security, what does it mean here in this view? The view is that they are guaranteed and trusted by the vendor or the producer or the procurer or the programmer. Unsigned, they are not trusted. Sign to sign signature, it is like that. But this is digital signature, is electronically set. Hey, this Java applet is trusted. I trust it. I guarantee it for you. So this is signed. But if there is no guarantee, it is not signed. Something like that. The application here provider declares a warning. So this Java applet is not signed. It's not signed. It's not signed. Unsigned Java applet. If there is no warning, so we can trust somehow. Next technology that web browsers also present them to us is they are the ActiveX. The ActiveX, they are technologies mainly implemented by Microsoft, and they run only on Microsoft web browsers, the Microsoft Explorer and the Microsoft Edge newly set browser. They are now actually being integrated as plugins with other browsers like the Chrome and the Firefox, but originally and still they are Microsoft product only. ActiveX, they are sort of a class or a library or a namespace where we have extra functionalities to facilitate the use of other functions. Actually, we can have controls. We can have features to add experience to the user, to add effects on the web views, and so on. So, like the JavaScript, it's something to add activity on the web interface, no more, no less. What's the problem here? The problem is that this is running in background and it's not to be seen by the end user, and it is causing an in-out flow with the external environment, like the JavaScript also. So we will have an inflow or an outflow from my device from my browser to the external environment, the public internet or the public network, in or out, without being controlling it. So this is a problematic view, because if there is any session hijacking or man-in-the-middle attack from any kind, and they gain, let's say, the access to the channel where this ActiveX flow is passing through, so this is a problematic view to my device. My device will be infected with all kinds of attacks in that scenario. The most catastrophic problem is that those ActiveX functions, they do not run on a sandbox. Means we can control them, yes, but they do not run on a sandbox. Means those are more free than when you compare them to the Java applets. Those are more dangerous than the Java applets. Those are more impactful on our device when we compare them to the Java app, because Java applets, we can control them completely in a web browser, and we can activate the sandbox and full stop. Those are controlled. But ActiveX, no, they do not run. They do not run on a sandbox or in a sandbox. They do not run. And this is the most dangerous aspect of those ActiveX. If they got hacked, the flow of this ActiveX, they have a direct access to the operating system. Direct access to the operating system. The operating system here meant is Microsoft operating system, the Windows, whatever, 7, 8, 8.1, 10 server, all of them, since they are running the ActiveX have an access to the operating system itself. We are running them from the browser, but they have access to the operating system. Yeah, because from the same procurer, same producer, Microsoft. Compatibility is 100%. thus this ActiveX is more dangerous than the other features, the cookies, the JavaScript, the Java. They are more dangerous than if they are actually dangerous if they are being compromised. But originally they are a technology. The ActiveX, it's a list of controls, it's a list of functionalities delivered over the web browsers, Microsoft web browsers, but they are technology to deliver services. They are positive from the beginning, yet they are posing security issues due to those prescribed points and much more. They are causing problems in case of a weak security framework. If they've been compromised, so they pose security concerns. Is it clear? Is it clear?
Yes, Mr.
If